I have a couple of motors here I'm going to have a look at. Some of these are very recent. This is a MuchMore FLETA ZX version 2s, and there's two versions of this. There's a standard version called the the ER, and there's also a version called the ST, which is a Sting. The Sting one is not legal. It's got various differences, which I'm going to have a look at and see how they vary. You can see them through these windows. The modern way of cutting out the cans so that the air flow can get through, but the exposed wires to try and keep them as cool as possible. So they're looking very interesting. I've also got some Team Powers motors here. This is the older version, this grey one, and it's been replaced by this one, which is a black, the new black finish, Actinium. As far as I know, this is the latest one, so I can compare them to two motors from MuchMore for 2017, the FLETA ZX V2s. There's the legal one and there's one called the Sting. They look very similar indeed. If you compare them side by side, superficially they look exactly the same. Until you look a bit closer, you can see there's a slight difference in the wire sizes on this one, and luckily they're marked up. This one says 17.5 turn type ER, which is a legal one. This one's 17.5 turn Sting, and also on the stator it's engraved on here, which you probably can't see. It says 17.5 turn ER, and on this one it says 17.5 turn ST. The rest of the motor, let's see, this end looks, the end bells look exactly the same, and of course from the front they look the same. Stack lengths, I think we'll measure them. Superficially, when you first look, they look the same. But that's the new FLETA ZX V2s is 17.5. It says 17.5 turn type ER on it. It looks like something from the future compared to another motor like like the Actinium from Team Powers. I mean, it looks like miles ahead in ideas. So massive holes. You can see the wire. It's got no plastic former, but they've kept the amount of insulation epoxy on the stator to a minimum. Holes all around. It's also engraved on here 17.5 turn ER, so there's no confusion about whether it's a legal one or not. Shimming, it's tight but it's tiny bit of movement, so perfect shimming. End bell, nice construction. There's even some slots in here, well, if they go all the way through, which will help even airflow even move through there. And the slots here allow access to the air to move. You can see the wires inside, so again airflow not being trapped inside. And the rotor's strong, not overly strong, but feels good. The timing is marked on this very small scale. There's a tiny little mark which is hard to see, but it says it's on the 30-degree point. It goes up 0, 10, 20, 30, 40, 50. So should be enough. I don't know if you can turn it past the 50. Nice solid solder tags. and the front solder ring is not overly massive like on some motors, so it hasn't blocked off airflow through the front as well, which is very nicely cut out. So a matter of just setting it up, testing it, see how it goes. 3 screws on the end bell, which is good for location and keeping it centered and solid. Very nicely made. One of the best made motors I've seen. Weight of the new FLETA ZX V2, 17.5, 148.5. Now that is lightweight. Resistance of the winding, 0.042043. That is good. There's the measuring the stator wire winding resistance on the Sting, 0.041, 0.040. So it's a little bit less again, the Sting version, than the standard one. Engraved on the end of the rotor on the Sting, it says 12.3-05SW, and on the standard one it says 12.5-07.25SY. Taking the Fleta ZX V2 17.5 turn ER version apart. First thing to notice that different to other manufacturers, the whole case and end bell assembly is one big piece of aluminium. That's how they've managed to make these massive slots, by making it all one piece, as rigid as possible. If they'd had a front plate, this would have had to be much thicker, where it all fitted together. So very clever indeed. You can see that the rotor has to be pulled out from this end, so putting it back in, you're going to have to make sure you don't lose any washers off the front. Looking at the rest of the construction, of course it's very open. You can see all the wires nicely here, and air gaps for air to flow, for cooling. Fairly well, neatly wound. Minimum construction, they've really thought about it. There's hardly anything in here that it doesn't need to be there. They've had to use this piece of plastic to fix these contacts to the wires on. They couldn't have left them floating in the air. They've been heavily riveted to the piece of plastic too, just to stop that flopping about, which you can get on some motors. One thing they haven't got is, you can't see, but where the wires come up and are soldered to this metal plate, some manufacturers now have a rivet that goes down over the wires. That means more solder can flow down and wrap around the wire and hold it for much better contact. On this one they still just have the wires poking up into the hole and just rely on the solder for passing the current, which we know can this solder can melt in some cases and also crack, but they haven't done that. As I said, the heavy rivets there are good, so these are solid. Nice open construction. You can see the quality of the epoxy on the Stator. Very nicely done, not too much of it. On some motors that epoxy's everywhere. The green, the front's nice and open. This round plate, as I said before, is not overly sized like on some motors, like especially the Orion, which is massive, which means again air can flow nicely. The end bell, simple construction again. This plate rotates, 3 screws. The sensor board is it's got a collar all the way around, which means that when they manufacture it, they can push it down tight and it's square, and they solder it into position so it's not wonky, which we've seen on plenty of manufacturers that just don't have the collar and rely on whoever solds it on to get it straight. Nice piece of aluminium, and there's just a little insulation goes on there. 3 long steel screws. Now the rotor, pretty standard construction. It's got a piece of light aluminium on the front that has been drilled for balancing. That's one way of doing it, as long as it doesn't come loose. I've seen these aluminium rings come loose on some motors. It's also got a nice rubber or nitrile, whatever it is, O-ring, which some manufacturers use, most don't, which is very good, which takes up, which means you can shim it tight, and when this expands with heat it squashes that rather than squeezing the bearings at each end, which is bad. There's a spacer on this end which you're going to have to make sure you don't lose, and there's some little spacers on the front again, which they're quite thick, so they don't seem to be worried about the fit, which means they must spec this up nicely. Lots of writing on this rotor, MuchMore. Right, let's measure the Gauss. 1357, 1365. So it's not a very high strength rotor like we've seen in some motors. We've seen them up to 1500. So this is going. We know about 1350, 1400 is very good in a touring car. We can measure the weights of the whole assembly. It's not going to be much good comparing it to other motors because this contains the whole case as well as the Stator, but be worthwhile comparing this version to the Sting version. So this weighs 102.6. Taking apart the Sting version, the first thing we notice is that the Stator slides out of the housing. It's not a perfectly tight fit. Now the standard version, the ER version, you can't. It's really tight. You could probably force it out if you wanted to, but it's not coming out easily. Which means that we can have a much closer look at the Stator in the Sting. As you can see, it's made up of multiple smaller diameter wires. So by using say a double wind instead of single winds, you should be able to pack more wire in. There's less air gaps between the wires. So it's equivalent in the old brush days when we used to use double, treble, triples and quad winds just to pack the wire in. But for pure brute force, even in those days, single wire always seemed to give the best brute force rather than multiple winds, which gave a much smoother revving motor and performing motor. Anyway, so you can see all the windings. Pretty neatly done. Otherwise, same construction as the other one. That is slid out of there. Now to compare the weights, we did the weight all together on the last one, so we better do it all together on this one. 122.1. The other one weighed 102, so that's where the extra weight comes from. The extra 20 grams, I should imagine that's from all that wire. They've managed to pack a lot more wire in. The end bell's the same, screws are the same. Now the rotor we know is totally different. It's got a different engraved description on the end, and it's got lots of writing on there, which I looked at earlier. It says MR-FZR ST, and then it also says 12.3 by 5.0 by 24.2 CE. So loads of information. See if we can measure the diameter. But it says 12.24. So on it it says 12.3, which I assume that's what it's supposed to be. So it's slightly under. So it measures 12.24. Measuring the other rotor carefully. get it square. It says 12.43. Measuring the Gauss on the Sting rotor, smaller diameter, but we know it's probably going to be stronger. Wow, look at that, nearly 1600. It is 1600. A very strong rotor, but smaller diameter, 1600, 1590. The magnetic length part of the rotor is about, can't quite get it on the ends, but you can see it's about 24.4, which considering it says 24.2 written on it, I guess that's the length, that refers to the length. The other one, it's near enough, 24.24, which is exactly what it says. 24.2 is actually written on it. Stator length, this is the ER version. Bit difficult to measure, you've got to get on the ends 19.78, and notice that there's very little epoxy on the ends, making it longer when you try and measure it, so that's a fairly accurate length, 19.78. Length on the Sting version, 19.65, which means it could be one lamination less than the standard ER version. Again, you have to be careful, there's some epoxy on the end, so it can give you, if you try and measure it over the epoxy, it's going to be a bit longer. I'm still impressed by the quality of manufacture of this motor. The epoxy is not all the way wrapped over the end of the stator that you've seen on some other manufacturers, which is, it's either been cleaned off after they put it on, or special holders so that you don't epoxy all the way around the edge. So the edge is exposed, meaning that you can measure the length very accurately. Most other ones I've seen that have been epoxy, the epoxy is all over the place. It's big lumps, thick, thin, wrapped around the end, which means that you have to virtually guess the length of the stator by holding it on where the ends of the metal laminations end. This one is very well made. Testing the Sting version of 17.5 at 6 amps. Pretty low kV, 2965, so it's not a massive high revving motor. It looks like it's going to be a mid-range torquey motor. Okay, the timing on the 17.5 Sting at 6 amps, that is where it is a bit unusual. It's very low, 39 degrees only needed. Good sensor board, 38, 39, 40. What does that mean? It means that it's going to have a very good wide power band, which means it's going to pull really well at low, medium and high speed, and it's going to run quite efficiently too, so you should be able to get a lot, overgear this without it overheating. Timing as shown on the marks on the end bell. The tiny little mark there is at about 45 degrees when the tester was showing 39. The ER version of the 17.5 Fleta ZX V2 set at 6 amps. Really nice high kV, 3585. Now that isn't achieved just because by a weak rotor, which can happen in some. This has got a nice strong rotor, so this motor is going to perform extremely well on fast tracks. The timing to achieve 6 amps on the ER version, 49 degrees average, sensor board not too bad, So it needs a lot of timing, but that's typical of high revving fast motors that we've seen before. So it's same sort of timing as other fast motors, but given a better kV. They've maintained some of the features of the old one, the shape of the holes that they've cut out. But this one now has a very solid front end, like all the manufacturers seem to be going to a big solid front end rather than the small thin one. Still not a lot of holes. In fact, they seem to have less holes on the new one than the old one. There's just a couple of holes here. You can see the wind 17.5 stamped on it. This one had a lot of holes all the way around. M-bells, still only 2 screws. Most manufacturers have gone to 3 screws, which holds the M-bell much more securely and locates it better. And they've gone from a window showing the advanced timing, as well as a little scale on here with nothing written on it, to just a scale now with advanced timing written on it from 0 to 60 and a little pointer. So they've changed that idea as well. Also on this one, they've gone from the thinner sort of PCB tags, which are not that great. They're difficult to solder to as well, to these heavy duty ones that a lot of people are using now, manufacturers. They're very heavy duty bits of like brassy sort of material that are bent over and give a much better place to solder, and should carry more current. And as I've already mentioned, the front's been changed with a big sort of machined aluminium part. 3 big holes for cooling, though the cooling is blocked off by a massive plate on the front, which blocks any airflow to go in through there. And there's only a small gap between the rotor and that plate. So, and this one, you could see some of the windings on this one. You see only a little bit of windings just through these holes here, and there's just 2 slots here that can measure the stack length. So I wouldn't say it was a brilliant step forward in the design from this one to this one. One thing you can tell just by turning, this has got a very weak magnet. It's obviously been used. I don't know whether it was always this weak or whether it's lost its magnetism. This one is nice and strong, hardly turn it over, and it's got some writing machined or stamped onto the end as well, giving you an idea what the rotor is inside. So I can also measure them. That's 17.5. That's a I think that's a 17.5. I mean, this one's it says 17.5 on it. This one you have to search around a bit on it to see what wind it is. In fact, I can't even see even through the slots what wind it is. So that's an improvement as well, because it's also written on the stack. You can see that. So those are those. I've also got one that's 17.5, and that's a 13.5 version 2. The old version of the Actinium sets a 6 amps, just over 3000 kV. Timing 45 degrees, 45, 47, 43, showing that the rotor must be fairly weak, because it doesn't need much advanced timing to get up to the maximum revs at 6 amps. The new Actinium at 6 amps, high revs now at 3273. Timing's only 41 degrees, and it's a good sensor board, 42, 40, 42. The mark on the M bell is very close to 40 as well. The weight of the new motor is about 164, 165, 164.8, and the previous one I measured was 169 grams, so it's lost a little bit of the weight, which is good. Resistance on the new Actinium is about 0.45, 0.46. Resistance on the windings on the original Actinium about 0.047, 0.048. Conclusions after testing the MuchMore FLETAs compared to other motors. I've got the results here. You can see there's a massive difference between the Sting version and the standard one. Now the standard one's got excellent kV when set up for blinky racing, and it's got very low winding resistance on the Sting one, not the lowest I've seen on the standard one. If you compare it to the Phantom, for instance, it's only 0.041 the Phantom, this is 0.042 winding resistance, and the R1 Works was also about 0.042, so it's in the ballpark. Compared to some others, the Team Powers was 0.046, and also the Orion was 0.046, meaning that the motors are going to overheat and they're not going to be as good as low winding resistances. Now the weight of the motor is excellent on the standard one, 148.5, that must be a class leader. I haven't had one that low before. The Works was 158, the Phantom 156. So that is very light, good saving in weight there. Gauss on the Rotor is about 1350. It's a bit lower than some of the others. The Works has got a 1450, Phantom massive 1500. So it's they've gone for a slightly weaker rotor, but it's going to be very revvy. It's going to be very good on fast circuits. The Sting version, yeah, it's got a lot of torque. It's going to be very punchy at low revs, mid-range. It's going to really be fast in and out corners. But top end, not great. You're going to have to gear it up a lot on very fast tracks to get the top end. So it looks like it's an indoor, small, twisty to up to a medium large. It'd be brilliant. Of course, it's not legal. So, MuchMore FLETA looks like it's a class leader. It's very futuristic looking. They've got the best cooling I've ever seen, and I reckon it's going to be right up the front with the best of the other motors.